I know it's a little bit dark right here, but that's okay. We're going to talk about headlight stuff, LED lights. Well, we're at the 2014 SAE Convergence, and we're in the Texas Instruments booth. And this is John Perry, and he's a marketing manager and an engineer with Texas Instruments. And John, tell us what's going on with this steerable headlight.
Well, what we've got here today, Jim, is our adaptive LED headlight system. So we're showing off a new product that enables our manufacturers and OEMs to create dynamic headlights that respond to steering wheel position, so you can do cornering light functions. It also can enable adaptive high beams, so that now you can run around with your high beams all the time without putting light in the window of the car in front of you or blinding the driver in the oncoming lane. So we really think this sort of technology is going to be very critical going forward, because it puts more light on the road where the drivers need it, makes it safer for everyone, and at the same time, there's really no downside. Now everybody can run around with their high beams, and you see better, more visibility without really any negative side effects.
Yep. And you know, a lot of you guys have been trying all kinds of high-intensity bulbs and all this kind of stuff, and I guess to a certain point that works. We're trying to see better, we're trying to be safer, but John, tell us a little bit more about the LEDs, how many of them there are, how you steer LEDs around. Boy, that's pretty interesting technology.
Yeah, so in this particular demonstration, we've got 78 LEDs. They're individually pixel level controlled. By that I mean we have 10-bit dimming resolution on every single LED within the module. That allows us to steer the light electrically. So now if you think back to the old Tucker automobiles that had the wheel that moved, or when the wheel moved, the light in the middle moved to try to do cornering. We can do that solid state today. No motors, no moving parts. They've got something that's very reliable, very robust. Oh, and by the way, LEDs are very efficient compared to other lighting sources. So really, like I said a minute ago, there's not a downside to going this way.
Right, absolutely. So instead of having a mechanical way of moving that light around the corner, you're actually turning LEDs on and off, or steering the light by using LED technology. That is really cool. But if you think that's cool, tell us more about that high beam stuff.
Yeah.
This is really good.
Yeah. So what we've got here is what we call the anti-glare function. And you can see that we've cut out a little slot out of the LEDs. I've got a colleague over here, Jim Patterson, who's helping me move around so we can position that. But if you imagine a camera, radar, whatever sensor is available on the car to detect other objects and motion of those objects, now you can identify a car and say, okay, I don't want to put light in this oncoming driver's windshield, so I'm going to cut this out, and it responds fast enough that we can steer the light completely around that vehicle without that driver ever perceiving it.
So if I understand this right, we leave our high beams on, but this system is capable of steering the bright away from the windshield of the oncoming car, and we're still high beam illuminating everything else, right?
Right, exactly.
That is really cool. Where's this headed for?
Well, loaded question, I guess. I think we're going to see more and more LEDs used in automotive forward lighting, headlights, and so forth. I think ultimately it's probably going to be some combination between LED and perhaps at a later date using TI's DLP technology. Essentially similar ideas, just different levels of gradients that we can control with each one.
That is just fantastic, and what a bright future we've all got ahead of us. So keep looking for this stuff. Someday you're going to have a vehicle with steerable headlights.